Welcome students. Now in this session we learn about trigonometric ratios. Naming the sides in a triangle. Now how do we name the sides of a right angle triangle in our trigonometry? Now first of all I will consider a right angle triangle. I will name the sides A, B, C. Now we know a right angle triangle has 90 degrees at one end and other two acute angles at two other ends. Let this be the angle where it has 90 degrees and A and C are the two other acute angles. In a right angle triangle we know the sum of all the angles will be equal to 180 degrees. Now how to name the sides of a triangle? Now if I consider the angle is present at A, if I consider the angle is present at A, I will assume that angle as a theta. Now what happens? The sides of a triangle. Now if I consider the angle is at A, then I will observe from the point of A. But from here, if I observe from here, you can observe that this is nothing but exactly opposite. If I observe from this one, this will be exactly opposite side, nothing but this will be the opposite, nothing but side BC. Now this is the first one, this is the opposite, exactly opposite to this one, opposite. Next, what happens to the other side? Now this is, and always in a right angle triangle, always remember that the longest side of a triangle is said to be the hypotenuse. Now if you observe this one, this is smaller than this one. Similarly, this also is smaller to this one. Now what happens this one? This is a bigger side. Now this longest side is nothing but always called as hypotenuse. The longest side of a triangle is said to be the hypotenuse always. Now this opposite. Now what about this one? Now this is nothing but, now if you observe from this one, this is the line which will be the below our side. This is nothing but called as adjacent. Now this side is said to be the adjacent side of a triangle. Now if you observe from this one, this is exactly opposite. So we say opposite side. And similarly for opposite side, if you observe this point, this line, these two lines, this is the upper and this is below. So this side will be considered as a adjacent side and this is considered as the longest side is always considered as a hypotenuse. Now this is how we name the sides of a triangle. Now what happens? Is there any changes if we change the angle to another vertex? So there will be nothing, the changes will be nothing but the position of the sides will change. Now if I go for another example, if I take another similar triangle BAC. Now if I observe, this is the right angle triangle. Here it will be exactly 90 degrees. Now previously I have taken the angle here. Now if I take the angle here, nothing but as I will observe the angle is present here. Now what happens to the names of the side? Now if I observe from this, since the angle is here, I will observe from this point C. If I observe from this point C, this will be the opposite side. Similarly, what I said, the below line is always nothing but the adjacent, and what I said, the remaining will be the hypotenuse, as well as I said the longest side of a triangle is always the hypotenuse. This is how we name the sides of a triangle. What is the trigonometric ratio? Now the trigonometric ratio is nothing the ratio of the sides of a right angle triangle with respect to its acute angles are called trigonometric ratios. Now if you observe, if you generally go for a right angle triangle, we know ABC is a right angle triangle and this AC are acute angles. Now what is this ratio? This ratio is nothing but the ratio with respect to its sides. There are three sides, AB, BC and AC. Now just look at it. Now there are 6 trigonometric ratios in a right angle triangle in our syllabus. Now in which there are 3 are the ratios directly and other 3 are called as multiplicative inverse of the 3. Now that are nothing but sine, cosine and tangent. The next one, cosec, secant and cotant. How the 6 trigonometric ratios can be defined in a right angle triangle. Now for that, first I will consider a right angle triangle ABC where it is angled at A. Now the angle is at A. Now first, what is the first trigonometric ratio? Sine. So I write sine of, where is the angle present? A. If the angle is at C, I should write as sine of C. If the angle is at B, I will take sine of B. Now here if I observe, here the angle is present at A. So I write down, I will compare each and everything with A. Now sine of A, or simply we can say sine A. Why I am saying A? Because the angle is at A. If it is at B, I will say sine B. If it is at C, I will say sine C. Now sine A is equal to, what is the ratio? I said nothing but the ratio of the angles with the sides, acute angles with sides. Now here if I go for the A, see in general in the previous explained, what is this one? If I go for this one, this is nothing but the opposite. Now this is nothing but the adjacent side, and this is nothing but the longest side is always said to be the hypotenuse. If I go with this one, if I observe from this point, it is nothing but, similarly this is opposite side, this is nothing but adjacent side, and the remaining this is nothing but the longest side is always called as hypotenuse. Now since it is sine A, I will go for A. If I observe, now what is the sine A, what is the sine ratio? Nothing but, what is sine definition? Opposite side to whichever angle it is, whether it is A, if it is B, if it is C. So here since we are with A, I will go for opposite side to A by hypotenuse. Opposite by hypotenuse. Now what is the opposite side to A here? BC, and by, and what is AC? This AC is nothing but the hypotenuse. Similarly, if we go for the cosine, cosine of A, or simply we can say cos A is equal to, what is the cos definition? Adjacent to any side by hypotenuse. Now what is adjacent to side here? A. Now what is adjacent here? If I observe from the figure, it is AB. So AB by, what is the hypotenuse? BC. Now the third ratio. What is the third one? Tangent of A. This tangent of A is simply called as tan A. Now what is tan A? Nothing but opposite to the side. Nothing but angle. Opposite to which angle? By adjacent to that angle. Is nothing but, what is the opposite here? BC by, what is adjacent? AB. Now this is how we will define the three ratios of a triangle ABC. Now we will learn about the multiplicative inverse of the ratios. Now the first one is nothing but cosec A is said to be the multiplicative inverse ratio of sin A. Nothing but cosec A is equal to 1 by sin A. This 1 by sin A is equal to 1 by, what is sin A in the previous? Opposite to angle A, opposite side to angle A by hypotenuse. Now you know this is nothing but A by B by C by D form. 1 by 1 is nothing but A by B form by C by D form. You know A by B by A by B by C by D is nothing but A by B into D by C. So here it becomes hypotenuse by opposite side of the angle A. Now similarly, this secant A will be equal to 1 by cosec A, where this secant is called the multiplicative inverse of cos equal to 1 by adjacent side to angle A by hypotenuse. Similarly, this will be equal to hypotenuse by adjacent side of the angle A. Now the last one is nothing but the cot A. This cot A is nothing but the multiplicative inverse of tan. 1 by tan A equal to adjacent side of the angle A by opposite side of the angle A. Now this is how we will define the 6 trigonometric ratios of a right angle triangle ABC. We move to a small first topic, naming the sides in a right angle triangle ABC. Now we will see the problem, page number 275. Do this. What is how do this problem is given? Identify hypotenuse as well as opposite side as well as adjacent side for a given figure. The first problem, the given is nothing but here is given PQR. He has given a triangle PQR, and here he has given the angles at P as well as at R. So here two acute angles are given at P as well as R. Now what we have to find out here? We have to find out the names of the sides, nothing but hypotenuse, opposite, adjacent for this triangle. Now here there will be possibilities of two questions. He may ask the question for P or he may ask for at R. Now look at the question given for angle R. Here clearly asked about angle R. So I should consider for angle R only adjacent, hypotenuse and adjacent opposite side. Now, so since he has given it R, I will go for R. I will observe from this one. Now if I observe from this R, now this is nothing but the opposite, exactly opposite to this R. Similarly, now if you observe the below, this is the below the is nothing but called as adjacent. Similarly, this one, the longest side, is always called as hypotenuse. So here, what is the hypotenuse here? First was hypotenuse. So what is the hypotenuse here? Hypotenuse is nothing but PR. What is the hypotenuse here? From the figure, PR is the hypotenuse. And what is the opposite here? What is the opposite side to R? Opposite side to R. What is the opposite side to R? Nothing but PQ. Now similarly, adjacent. Similarly, therefore, adjacent side. What is the adjacent side? Adjacent side is nothing but QR. Now, in this way, we can solve the problems or we can identify what is opposite side, adjacent and hypotenuse for given angles. Now here only for R is given. Similarly, we can find out for P. Similarly, also we can find out for Q. Now this is how we will name the sides with the respect to given angles. Number 275, try this. Now, the question given is that write the lengths of the hypotenuse, adjacent side and opposite side of the following figure given. Now the figure given is that CBA is a right angle triangle where two lengths are given. Nothing but the length between C and A is nothing but 5 centimeters. Similarly, C and B, the length is nothing but 4 centimeters. Now if you observe, generally for a right angle triangle or rectangle we know 3. Now here there are only two lengths are given and the third length is not given. Now how to find out the third length? And it is also asking the angle at C. For angle C, we have to observe at C. Here there are angle A also is present. First we will solve the angle C only. Now you may get a doubt. Only two lengths are given. How the third length can be found out? Now for this, in the previous classes, we have learned about the Pythagoras law. What is the Pythagoras law? Sum of square of two sides is equal to third side. Now I will go for that. What is the Pythagoras law? It is nothing but hypotenuse square is equal to side square plus side square plus side square. Now, what is the hypotenuse? If you go for this C, this will be the opposite and this will be the adjacent. Similarly, the longest is always said to be the hypotenuse. This is the naming the sides of a triangle CBA. Now, BA is the opposite where its value is unknown and CB is the having the as adjacent as 4 centimeters and hypotenuse is having the value as 5. Now we will find out this by using the Pythagoras law. Hypotenuse square is equal to side square plus side square. Now what is the hypotenuse value be there? 5. I will replace the value is equal to what is the first side or nothing but take as AB. I will take one side as AB unknown plus what is the second side? The second side is BC. Now here hypotenuse is nothing but AC. Now what is the AC? The lengths are given. So that is 5 square is equal to AB is unknown, AB square plus BC is nothing but 4 square. Now 5 square is nothing but 25, which is equal to AB, I don't know the value, AB square plus 4 square is nothing but 4 for the 16. Here I need the AB square value. So here I down AB, I'll keep the AB there only, and I'll take this 16 to this side. So it's 25, it becomes plus 16 becomes minus 16. Now I know 25 minus 16 is nothing but 9. Here I know AB square is equal to 9. Here it is having the square. First I will try to write the 9 as a square if is possible. Yes, I can write down this 9 as 3 square. 3 3 is a 9. Now both sides the square will get cancelled. Now what is the AB value we got? 3. What is this 3? AB is nothing but the opposite side, which will be equal to 3. Now we got the AB value as 3. Now we will find out for angle C what are the lengths of the sides. So hypotenuse. What is hypotenuse for C? AC, which is equal to 5 centimeters already given. Similarly, adjacent BC is also given as 4 centimeters. Now what I have found out? The opposite side AB, which is equal to 3 centimeters. This is how we will find out the value of the unknown sides and will solve the problems.